Okay. Let's take a look at this. How would we describe this end behavior? How would we start? Yep, as x approaches infinity, so that means we're looking at our right arrow, which is where I usually start. Ooh. Whatever our function is, we can call it y, we can call it f of x, we can call it g of x, whatever we want to name it. Since that's going up, we also say that's approaching infinity. That tells me my right arrow going up. So how do we describe the left arrow? Boom shakalaka. You can say y or you can say f of x. Either way is totally fine. But my left arrow, as x approaches negative infinity, that's this guy over here. He's going down. So we say that's also approaching negative infinity. How many roots does this function have? Listen. Roots. Remember that has several synonyms. Solutions, zeros, x-intercepts. Those all mean the same thing. No, it is not. Just one. Yeah, it looks like it is. It's a cubic. It's just being weird. It's just getting really close and it only goes poof through right there. Yeah, so this one just has one solution. If we had solutions like at -1 and 1 here, it would have to go up, down, up like that to be able to go through all three of them. So it would be very, very visually apparent if we had three separate ones, even if they were really close. So if it just squishes through, it's just one. If it's separate pieces, it will be clear. Questions on that? Awesome sauce. So we're going to look at page 4 in the notes packet. We have question 2 at the top where we're going to talk about all the things that you talked about yesterday and some sketches at the bottom that we're going to use to kind of help us practice. And then there's more on the next page we might try some more. So we talked about it yesterday, but we didn't get a ton of time practicing with our degree and leading coefficient. It's because we had a lot of stuff to go through. What is our degree on this one? It is 2. Our degree is our highest exponent. So it's always going to be whatever our biggest exponent is. So our degree is going to be 2. The second thing we are asked here is what is our leading coefficient? And just as a reminder, that is the number in front of whatever our biggest degree term is. -1. So the degree we want first, it tells us which piece is in charge. The number in front of that one is our leading coefficient. We've got our -1 here. So they're not always going to be in order. A lot of times they are, but sometimes they won't be, and they'll be scrambled on us. So our degree and our leading coefficient, questions on how we find either of those two pieces. Because we need both of those pieces to do our end behavior, and we're going to be really careful because our end behavior is set up backwards here. We usually start with our positive and the negative ones on top here, so just be careful. When we're looking at our end behavior here, what we really care about is my degree even or odd? So is this number even or odd? Even. Is my leading coefficient positive or negative? Negative. So if we think about evens that are negative, so remember we have odd, where's the disco? And evens very, very matchy-matchy. So if I have evens, that means we're going to be matchy-matchy. They're either both pointing up or they're both pointing down. Are they both going to point up or are they both going to point down? Down. Because this negative sign is always going to match what happens to our positive infinity. So our leading coefficient is always going to tell us what happens with the right arrow. So I know my right arrow is going to go to negative infinity. Negative infinity. And since we know it's even, we know it's very matchy-matchy, I know that the other arrow also needs to go to negative infinity because even functions go to the same direction. So my leading coefficient tells me the sign of my right arrow. My degree tells me if we're going to be the same or if we're going to be opposites. So if we were wanting to see what this thing kind of looked like, I could do a full proper sketch, but this is going to be something that has down arrow on the left, down arrow on the right. It's going to be some sort of frowny face parabola. My degree is 2. I might have real solutions. I might not. We don't have enough information at this point. We'll get to the point where we actually do. But we don't have it right now. So we're just kind of getting a vibe of it. We don't have to go through and do a full sketch on each one of these. We'll do some where we sketch them and some where we don't. But you can make yourself visualization. These are pieces we've seen before. Questions on A? Because we're going to practice this a couple of times because our degree and our leading coefficient and our end behavior are going to come back around fairly frequently. So let's look at B. Very similar. Similar pieces. We've got our g of x, which is not the same as what's in your book. I'm going to... There we go. Now it matches what's in the note packet. There you go. Ta-da. Mine's going to match yours. So our g of x, which is x cubed minus 5x squared plus 6x. There are things we could do here. I could try and factor some stuff. I could get down to solutions. I'm not gonna though. All we need to do is find our degree and our leading coefficient so we can figure out what happens with our arrows. What is our degree? 3. What is our leading coefficient? 1. It's the number in front of that term. So our leading coefficient here is 1. So is this function even or odd? I've heard one of each now. It is odd. Our degree is how we make that choice. This is an odd number, so it is odd. The degree lets us choose between even or odd. Are we positive or negative? positive. A good way to remember that is with our polynomials, we are never going to have negative exponents. So there is not a way our degree could be negative. So this will always be a positive number. This is the only piece that we're looking at that could be negative. So this one is going to be even or odd because there's no way that that could be negative. If that helps us kind of remember which one's which. So that lets us know what we're going to do for our end behavior here. If I know it's odd and positive, I know my right arrow is going to point which way? Up. My right arrow is always going to match this leading coefficient.
Technically, it's not wrong. It's not wrong.
Right arrow is going to point right, but it is going to point up more. It happens. It is 7 o'clock in the morning, y'all. 100% understand boot up errors happen. There are errors like that's processing time. I get it. I promise. As I say, it took me a minute to process it. I didn't even just going past it. So our right arrow is going to point up. We've got this positive leading coefficient. So my right arrow, as it approaches positive infinity, is going to go up. Again, they didn't write half of it, and they put them in a weird order. So as x approaches infinity, my function g of x needs to approach infinity. It's positive infinity. And whether you put g of x or f of x or you put y, it all does the same thing. It's just different costumes. But our leading coefficient tells us that this is going for our positive infinity.
I'm pulling up.
For safe trick or treat, yes. For Halloween day, probably not twice in 1 week.
Why?
Because it's twice in 1 week and it's 7 o'clock in the morning.
Yeah, but it's going to be like.
It's all we only give them a chance.
It's gonna be,
And it's on a Friday.
Exactly.
It is.
It's not gonna be 7 a.m.
I'm bringing.
You're right.
I'm bringing it home at 2.
bring it home.
Yes.
I was going to say you can't wear a mask during the day. Dress code, security issues. So, just saying. So if we know our right arrow points up, what's going to happen with our left arrow? It's going to go down. Because odds go in an opposite direction. Odd ducks go to the disco. Odds go in opposite directions. So our function's going to approach that negative infinity. If we have an odd function, they go in opposite directions. If we have an even function, they're matchy-matchy. Even has sameness, odds are opposites.
So since it's odd, it'll be negative.
Then our left arrow goes negative. All right, let's look at C, and then we'll look at those sketches down below. All right. Just thinking of it. So take a look at this one. We're going to find what's our degree here. 5. It's our biggest exponent. And what is our leading coefficient? -1. So are we even or odd? Odd. Positive or negative? Negative. So odd and negative means we know. What? Y goes to negative infinity. Our leading coefficient always tells us what happens at the right arrow when x approaches positive infinity. We need to make sure we're watching carefully. Occasionally these get swapped. A lot of times if I typed it, we put the positive on top. Someone else types it, a lot of times we put the negative on top. So sometimes they can switch. We need to watch carefully. That is not one of those things that it has to be in a certain order. It can flip-flop back and forth. We just need to be careful and observant. So if we know that our y goes to negative infinity when x goes to positive infinity, what happens when x goes to negative infinity? Where's y going to go? Positive infinity. Because odd functions go in opposite directions. Okay. Cool. Questions on these ones? So from this, we could get ourselves little baby sketches. I know how these arrows are going to look. My left arrow is going to point up. My right arrow is going to point down. This is going to be wiggly squiggly somehow. It might not look very squiggly. It might look like that. We don't know how the middle looks. We're just getting kind of vibes on it. We're getting our arrows. We're figuring out what's going on. So we could do any number of things when it comes to a sketch of these. We don't have exact answers. So we're going to get as close as we can. And so if we look at the bottom, it kind of gives us thoughts on these things that we're going to try out. So we're going to do sketches. These are not going to be proper graphs. These are sketches. It's a thought. It's a vibe, not perfection. So we're going to look at a cubic polynomial that has a negative leading coefficient and 3 distinct real roots. What that means is it has 3 different roots. That's what that means. Distinct means different. So we need this to have 3 roots, be cubic, and have a negative leading coefficient. Do you remember what cubic means? 3. That's going to be an x to the 3rd. Cubic means x to the 3rd. If they said something like quadratic, that's our x squareds. Cubic is x to the 3rd. It would be rare and unkind to say quartic. Think quarter, quartic, 4s. Quintic is 5s. I could keep going in the Latin ones, but it's just not a thing that's typically used. We very rarely use the even quartic or quintic. Cubic is about as high as we go in the names. So quadratic means x squared. Cubic means x to the 3rd. Most of the rest of them we just say to the 4th, to the 5th, to the 6th. So if we know we have a cubic polynomial with a negative leading coefficient, how does that help me with a sketch? This is going to be an odd function. So we have opposite arrows. And which way is the right arrow going to go? Down or up? Down. Because we know our negative leading coefficient. So our right arrow is going to go down. Which I just wrote with the fewest amount of words possible. Our right arrow is going to go down. Or you could put that as, our x approaches infinity. Oh, snap. Y is going to approach negative infinity. So I know somewhere over here we're going to have a down arrow. Since I know we have an odd function, that x to the 3rd, we're going in opposite directions. My left arrow is going to go be up. So I know these 2 arrows. And we're asked to give it 3 real roots. So I want 3 x-intercepts. I'm going to pick 3 spots. We're not told anything about our 3 roots. Maybe I have one here. Maybe I have one here. Maybe I have one here. I'm just making up spots. I happen to pick -3, 0, and 2. But you could pick -4 or -1 or positive 4. I wouldn't recommend something like 10. It's going to be off the paper. And then we're going to connect these up. When we're dealing with polynomials, these are always going to be functions. So we can make cool looking roller coasters as long as there's no loop-de-loops. Do not do something like that. That is bad. That's what I mean by no loop-de-loops. We can do wiggle squiggles. I can come down this. I could make it taller. I could make them shorter. I could make it as darker so it's easier to see. And that's our sketch here. We don't have enough information to get more detailed than that. If I was given an equation, I could pick some numbers, guess, and check and find points, but we don't need to. So a lot of times on these sketches, we're going to put our end behavior and we're going to connect them. Maybe with a wiggle squiggle, maybe just with like a line. So let's try another one. So looking at B here, we've got a quadratic polynomial with a positive leading coefficient and no real roots.
God forbid a man is locked in.
He's laughing, but okay.
Whoa, what if he's trying to mad funny?
What is funny about?
What if he's trying to make it interesting for himself? So, God forbid a man is trying to find
He was looking at us and laughing. Why are
He was
you
looking
like?
forward.
No, he
let
was
him
not.
like pay attention. More too much of a distraction.
You are.
Oh,
You might need a red slip.
You're the one
Please
who's.
calm down.
You need a red slip. You're the one who's.
Uh,
I wasn't even saying anything. Like.
Breathe, children. All right, so B here, we're looking at a quadratic polynomial with a positive leading coefficient and no real roots. So quadratic, we've seen that before. We've had that word before. What is a quadratic again? 2. That's when we have our x squareds. Our whole last chapter was over quadratics. Oh, snap, what? So a quadratic polynomial still is just going to have an rx squared. We have a positive leading coefficient. And no real roots. So those are kind of our important pieces here. So is this even or odd? Even. Our degree tells us it's even. Are we positive or negative? Positive. That's our leading coefficient that tells us if we're positive or negative. So that's enough for us to get our end behavior. Like I could write the whole thing out if we wanted to. I could say, as x approaches infinity, my right arrow is going to point which way? Up. My y approaches positive infinity because we have that positive leading coefficient. So my right arrow is going to point up. My leading coefficient always tells me about the right arrow. Since this is an even function, what does that tell me about the left arrow? It goes to the same side. So as x goes to negative infinity, what happens to y? Positive infinity. Because we're even, they go the same direction. So since it's even, my left arrow is going to point up. And we know I've got these 2 arrows, and we want this to have no real roots. What does that mean? It's going to happen for my x-axis. So what's going to happen down here? Nothing. We don't touch it. I don't like it. I don't want to see. Like, no, we don't touch it. So no real roots means no x-intercepts. It is never crossing my x-axis. That's this guy right here. I have no real roots. We have only imaginary answers. Only imaginary numbers for answers. Because we've solved stuff like that. Finding our solutions and using our quadratic formula. Last chapter we had those. Okay. One more of these kind of sketches. So we've got a cubic polynomial with a positive leading coefficient and one real root. So our cubic polynomial, that word cubic tells us what? Yeah, that's going to be our x to the third. So we have our degree of 3. What else do we have in here that we need? The positive leading coefficient is another important one. We also will need the root thing. So our positive leading coefficient tells us that our leading coefficient is positive. So I'm not going to forget it. It's plus. So we're degree 3 and positive. So are we odd or even? Odd. And are we positive or negative? Odd and positive. That tells us about our end behavior. I know my right arrow is going to match that sign. So if we wrote this out as x approaches positive infinity, my right arrow, I know whatever my function is, my y is going to have that same sign, that positive infinity. My right arrow has to point up. And for our as x approaches negative infinity, our left arrow, what's going to happen? Which way is our left arrow going to point? Down. How do we know down? Because our degree is odd. Absolutely right. Since our degree is 3, that's odd, and odds go in opposite direction. So since the right arrow goes up, my left arrow has to point down. Has to. So we want to connect those 2 arrows, only having one real root. So we want to make sure we only cross our x-axis one time. And there are lots of different ways you can draw this. You could give me essentially a line. I don't recommend it though. It's the least cubic of the options. I could do one that looks very much like the bell work, where it's just a squiggle and it goes through. You could do a wiggle squiggle and just have the wiggle squiggle not go through the x-axis. I could have it happen on this side. So there's lots of different ways we can draw these. There's definitely some creative choices in here. Like, as long as we don't do this, where we have 3 real roots. Boop. We don't want to do that. So any of those would work just fine. We don't have the details to get more information than that. If I knew where my y-intercept was, that would be helpful. If I knew where the root was, that would be helpful to get this sketch to be more accurate. We just don't have the information. So we know where the arrows go, and I know there's only one root, but I don't know where it is. I don't know where anything wiggles or squiggles. We're just getting it as close as we can, and this is as close as we can get. Okay? So when it comes, when we're looking at that homework and it says sketch, get me end behavior, and that's kind of it. End behavior, wiggle squiggles. We do not have to do super detailed on these sketches. Because like homework, or question 1 on the homework mentions the sketches. So we can also look at these sketches and kind of work our way backwards. We can look at arrows and figure out my leading coefficients. If my right arrow's up, my leading coefficient is positive. If my right arrow's down, my leading coefficient is negative. If both arrows match, we know it's even. If both arrows don't match, we know it's odd. So we can find all kinds of pieces from looking at these pictures. And honestly, that's what a lot of the back is looking at equations, figuring out our degree and our leading coefficients. We could tell that. And give me 1 second. There we go. I want to do this one real quick. So on the very next page, we're going to do the first one, and then we'll do the rest of them tomorrow. I'm just going to poop like that. There we go. Sorry, I'm messing with my page settings. There we go. Just trying to make sure everything stays there. So let's look at A on this next page, just so we can kind of practice this. Because this is what several of the ones at the back of the homework are like, and I want us to see it. So when we're looking at a polynomial and kind of combining together all the things we did today, our degree comes from our biggest exponent. So looking at this polynomial here, what is our degree? 3. Our highest exponent is that 3. So this guy is the degree. What is our leading coefficient? 1. It's always the number in front of that term that has our biggest exponent. So if this instead was like x to the 5th, then this guy would be in charge and our leading coefficient would be -4. So it doesn't matter if it's the one in front, it's what is in front of our highest degree. So our leading coefficient here is in fact that 1. So is this even or odd?
Odd.
This one is odd. Our degree tells us if it's even or odd. Are we positive or negative?
Positive.
Positive.
What you said?
So we can then fill in our end behavior here. As x approaches positive infinity, so notice that these are swapped again. What happens to my function? Positive infinity. As x approaches positive infinity, it's going to always match that sign of our leading coefficient. I know my right arrow is going to point up. So what is going to happen to my left arrow? Oh, this one? It's going to go down. Because we have an odd function here, that means we know these are going to go in opposite directions. So if one arrow points up, the other arrow has to point down. Odds go in opposite directions every single time. What is the most number of zeros this function can have? We mentioned it briefly yesterday. 3. It's our degree. This one can have, at most, 3 real zeros. It could have just 1. It could have 2. It could have 3. It cannot have 4 real zeros. It can't have 4 solutions.
It has 3 real zeros because.
That's a degree. our degree is always going to tell us the most it can have. It's not that it does have 3 zeros. It could have that many.
Okay.
So if we ever are like trying to solve this and get solutions and I wind up with 5 answers, something went wrong. So it's a little way to give us a spot check. So when it comes time for things like this on sketches, just because there's some on the homework where we're doing a little sketch, a lot of times we'll get a picture like this. I'll say, well, I know my right arrow goes up. I know my left arrow goes down. There's not a whole lot else we know. We do know one thing. What's the y-intercept of that function? 7. So I could get slightly more detail. I know my y-intercept is 7. So at some point, it's going to hit there. Other than that, I got nothing. So when we make our sketch, it could be that. Could be that. Could be that. We don't have any more information. So this would be if we had 3 real roots. This is what it looks like if we have 2 real roots. Or we could have, the wrong button. We could have just 1 real root. And we don't have the information to be able to get there yet. I'm just going to leave it like that. Okay? So when it comes to the sketches, we don't have tons of information. If we include the y-intercept, great. If you don't, and you just work with end behavior, also okay. So tomorrow we're going to practice with these a little bit more, but they're not particularly worse than this. Okay? So we're going to practice with these a little bit more. We're going to do some sketches. We're going to practice identifying stuff from the sketches, all that jazz. So you guys should already have homework 1. Tomorrow, I do need you guys to bring your computers because we have to actually practice joining a Teams call because reasons. Say that again? November the 4th. Tuesday. It's the Tuesday after Halloween. But when we show you guys how to join a Teams call, apparently we have to actually make you join a Teams call. So bring your computer so we can click the button and do the thing and I won't get in trouble. Because they're whining they haven't done it. So, like